All right, so this is a video for the first test for chapter 3. There's no part 1 and part 2, but the solving equations. The area of a right triangle is 9 feet. Find the height of the triangle. So here we have the height is x minus 4 and the base is 2x minus 3. So we know that triangles are 1/2 times the base, 2x minus 3, times the height, x minus 4. And that area is going to equal 9. So I think the easiest thing to do is times it by 2. And so we get 2x minus 3 times x minus 4 equals 18. And then we'll FOIL this out. 2x times x is 2x squared. 2x times negative 4 is minus 8x. Negative 3 times x is minus 3x. And negative 3 times negative 4 is plus 12. That equals 18. We're going to move this 18 to the other side, so we get 2x minus 11, or 2x squared minus 11x minus 6 equals 0. And we're going to try to factor this first. It has an x term, so square roots aren't possible. So I know I can do 2x times x. And if I put 3 here, how about 6 and 1? If I do a 6 here, that's 12x. And a 1x, I can make that a negative if it's minus 6 and positive 1, because negative 12 plus 1 is negative 11, and 1 times negative 6 is negative 6. And so we have 2x plus 1 equals 0. So we get 2x equals negative 1, and x is negative 1/2, and we get x equals 6. So we can plug those in. If I plug in 6, 6 minus 4 is 2, so the height is 2. If I plugged in negative 1/2 minus 4, I get negative 4.5, and that doesn't work because height cannot be negative. So the height is 2, and the x value is 6. Number 2, 3, and 4 ask how many solutions. So that asks us to use the discriminant with this b squared minus 4ac. And we know if that is greater than 0, there's 2 real solutions. If it's a perfect square, they're rational. If it's not a perfect square, they're irrational. If it's equal to 0, there's 1 real rational. And if it's less than 0, there's 2 complex. And that's all we need to do. We need to find the discriminant and then determine which it is. So for number 2, I have a equals 1, b is negative 4, and c is negative 2. So b squared, negative 4 squared, minus 4 times a times c, 4 times 1 times negative 2. That's 16 plus 8, which is 24, which is positive, which is not a perfect square, so there's 2 real irrational roots. For number 3, my a is 3x squared, my b plus 1x, so b equals 1, and my c is positive 2. So 1 squared minus 4 times 3 times 2, b squared minus 4 times a times c. That's 1 minus 12 times 2 is 24, so negative 23, which makes that 2 complex roots. And then number 4 is 3x squared minus 6x plus 3. So that's a is 3, b is negative 6, and c is 3. So that's negative 6 squared minus 4 times 3 times 3. 36 minus 12 times 3 is 36, gives me 0. So there's 1 real rational root. Okay, so we're going to take a little picture of these and we're going to copy them onto the next page. What just happened is so these say solve by factoring. so number 5. To factor, I need to get it equal to 0. So for number 5, I'm going to 3x squared, I'm going to add 6x, and I'm going to subtract 45. Okay, so I plus 6x and minus 45 to both sides to get it all equal to 1. And I notice that I can divide everything by 3. So I get 3 times x squared plus 2x minus 15 equals 0. And now I have one that's nice and easy to factor. What two numbers multiply to negative 15 and add to 2? Well, positive 5 and negative 3. So that's x plus 5, x minus 3 equals 0. And because it says to solve by factoring, I need to get x plus 5 equal to 0, so x equals negative 5. And x minus 3 equal to 0, so x equals 3. Number 6, 4k squared minus 49. I'm going to minus the 1 from both sides, equals 0. Now I have subtraction, so that's difference, and 4 and 49 are both perfect squares. So this is a difference of squares, 2k plus 7 and 2k minus 7 equals 0. So I set each one equal to 0 and solve. Minus 7, 2k equals negative 7. So k is negative 7 halves. And plus 7, so 2k equals 7. So k is equal to 7 halves. Number 7. We'll switch to blue just to make it easier to kind of see. Minus 8y squared plus 12y equals 0. So I don't have a constant term, so I can take out a 4. I'm going to take out a negative 4 because I can divide 8 and 12 by negative 4 and a y. Negative 4y times 2y plus 3 equals 0. So negative 4y equals 0, so y equals 0, and 2y plus 3 equals 0. Subtract the 3. 2y equals negative 3, divide by 2, y equals negative 3 halves. So my two solutions are 0 and negative 3 halves. Number 8, 5x squared minus 13x. I'm going to move the 6 to the other side, so minus 6. And this is, again, solved by factoring. So I know the only way I can get 5x squared is 5x times x. So 5x times x. And I have 6 times 1 or 3 times 2. And I need to get 13x. So let's try 3 times 2. My outside is 10x, and my inside is 3x. Well, that gives me 13 if they're both negative. It gives me negative 13. The problem with that is it gives me a positive 6. So that one doesn't actually work. Let's try switching it and see what happens. What if I put 2 here and 3 here? I get 15x and 2x. Well, that can give me a negative if I have negative 15 and positive 2, and that's going to give me opposite signs, which will give me the minus 6. So I can set 5x plus 2 equal to 0. So 5x equals 2. So x is 2/5, and x minus 3 equals 0, so x equals 3. So I have 3 and positive 2/5. And number 9, x squared minus 6x plus 5 equals 0. What two numbers multiply to 5 and add to negative 6? Negative 5 and negative 1. So x minus 5, x minus 1. So x is equal to 5 and positive 1. Okay, so this set of problem is solving using the square root property. So we're going to get the square term by itself, so we're going to add 6. So I have 4x plus 1 squared equals 36. And to undo the square, I take the square root. I can't deal with what's inside the parentheses until I get rid of the square root. And so we get 4x plus 1 equals plus or minus 6. And we could subtract 1, so 4x equals negative 1 plus or minus 6. And divide by 4. So x equals -1 plus or minus 6 over 4. And then some of you like to leave it like this, and that's not okay. You got to do -1 plus 6 is 5 over 4. And -1 minus 6 is -7 over 4. And you get your two answers. Number 11, going to get the square root by itself still. Add 19 to both sides. So 3n squared equals 21. Divide by 3. So n squared equals 7. And then we'll take the square root of both sides. So n equals plus or minus the square root of 7, and I can't simplify that anymore. Number 12. Zero equals 6 times the quantity of x minus 2 squared plus 2. So I'm going to start by subtracting 2. So we get -2 equals 6 times x minus 2 squared. And then I need to divide by 6. I can't distribute into that because it has the square. So I get -1/3 equals x minus 2 squared. And I'll take the square root of that. And I'm going to write the x minus 2 on this side just because I like it like that. Equals I over the square root of plus or minus I over the square root of 3. And I have to rationalize that by multiplying by the square root of 3 over the square root of 3. So I have the x minus 2 equals plus or minus I square root 3 over 3. And then we can add 2. Remember that we're always adding it in front of the plus or minus. So x equals 2 plus or minus I square root 3 over 3. And then number 13. Zero equals x plus 3 squared plus 8. I'm going to minus 8. And we get -8 equals x plus 3 squared. And I'm going to plus or minus the square root on both sides. So I have 8 is 2 and 2 and 2. So there's plus or minus 2i square root 2. It's I because it's negative. And then I'm going to subtract 3. And it's in front. So -3 plus or minus 2i square root 2 equals my x. All right, so now it says solve by completing the square. And so we're going to do that. X squared minus 4x equals -3. I'm going to move the constant to the other side because I already have a coefficient of 1. It's not a perfect square. And we're going to add something to both sides that will make the left side a perfect square trinomial. So it's -4 divided by 2. B over 2 squared is how we figure out what that is. So -2 squared is 4. So we're going to add 4 to both sides. And then we get x minus 2 squared. That's how x squared minus 4x plus 4 factors equals 1. And then we can square root both sides. So x minus 2 equals plus or minus 1 because the square root of 1 is 1. And then we can add 2. And I also see kids leaving this as their final answer, which is not okay. 2 plus 1 is 3, and 2 minus 1 is 1. You need to give both answers when you can. The only time we can leave it if the plus or minus parts is imaginary or a radical. So number 15 is 2x squared plus 10x plus 5 equals 0. We have to get the coefficient equal to 1, so we have to divide everything by 2. So x squared plus 5x plus 5 halves equals 0. And we're going to move the constant to the other side. -5 halves plus something. And this is 5 halves. 5 divided by 2 squared is 25 over 4. And so we're going to add 25 over 4 to both sides. I prefer to have that in a different color. And we know that this is how this side's going to factor x plus 5 halves squared. And I can multiply by 2 over 2 so that I get a common denominator. Negative 10 fourths plus 25 fourths is 15 fourths. And we're going to square root both sides. Get x plus 5 halves equals plus or minus square root of 15 over 2. And then we're going to subtract 5 halves. So x equals negative 5 halves plus or minus the square root of 15 over 2. I can't simplify the square root of 15 because 5 and 3 aren't perfect squares. And that's my final answer. If I wanted to, I could make that as one fraction. And lastly, solve by the quadratic formula. Again, we have to get it equal to 0. So 3x squared minus 6x plus 2 equals 0. My a is 3, my b is negative 6, and my c is 2. So it's negative b, so negative negative 6, plus or minus the square root of negative 6 squared, minus 4 times 3 times 2, all over 2 times a, which is 3. So remember, it's negative b plus or minus the square root of b squared minus 4ac, all over 2a. So that's 6 plus or minus 36 minus, that's 12 times 2, 24 over 6, which is 6 plus or minus the square root of 12 over 6. The square root of 12 is 4 and 3, so that reduces to 2 square root 3 over 6. Now, because these all are divisible by 2, I can simplify. 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, so 1 square root 3, and 6 divided by 2 is 3. So 3 plus or minus square root 3 over 3. I cannot divide that 3 into the radical, so I need to leave it. 17 is 4x squared plus 2 equals 0, where my b is 0, my a is 4, and my c is 2. So 0 plus or minus the square root of 0 squared minus 4 times 2, all over 2 times 4, which is plus or minus the square root of negative 16 times 2 is negative 32 over 8. Now I can't divide into that radical. The 32 is under a radical. It can't get divided by that 8 unless it's under a radical as well. So 32 is 16 times 2, which makes it 4i square root 2 over 8. And now I can simplify the 4 and the 8, plus or minus, hold on, it's just going to be 1i square root 2 over 2. And lastly, number 18, that's negative 2x squared plus 4x minus 1 equals 0. So my a is negative 2, my b is 4, and my c is negative 1. So that's negative 4 plus or minus the square root of 4 squared minus 4 times negative 2 times negative 1, all over 2 times negative 2. So negative 4 plus or minus the square root of 16 minus 8, because it's negative 4 times negative 2, which is positive, times the negative 1 makes it negative again. So over negative 4. And then negative 4 plus or minus the square root of 8 over negative 4. So negative 4 plus or minus, that's 2 square root 2 over negative 4. I'm going to divide everything by 2. So that's, I can divide it all by negative 2 as well. But negative 2 plus or minus square root 2 over 2, over negative 2 still. And if I divide everything by negative 1, it becomes 2 plus or minus the square root of 2. I could put minus plus, but that doesn't make a difference over positive 2. Find the zeros. This one says find the zeros. This might be out of order. Find the zeros mean make it equal to 0 and then solve it. So here we're going to choose our method. When I see the x squared and x and no constant, I immediately want to factor x minus 9. And so x is equal to 0, and 7x minus 9 is equal to 0. And add 9, 7x equals 9, x equals 9/7 and 0. So this is number 19. Number 20 is x squared minus 3x minus 40 equals 0. It doesn't matter what side I put the equal 0 on, but finding the 0 means find when it equals 0. And I want two numbers that multiply to negative 40 and add to negative 3, and that's negative 8 and positive 5. So x minus 8, x plus 5. So x is 8 and negative 5. And for number 21, 0 equals 8x squared plus 30. We're going to solve using algebra because we're missing the bx term. So negative 30 equals 8x squared. Divide by 8. Let's simplify that to negative 15/4 equals x squared. And we'll square root both sides. Now sometimes you'll see me simplify the fraction and sometimes you won't. I simplify it when I don't have perfect squares in the top or the bottom. In this case, 8 is not a perfect square, but if the bottom was already a 4, I would leave it. And so I get x equals plus or minus I square root 15 over the square root of 4, which is 2.